Hi everyone, this is Mrs. Bokerman, and this is part 2 of Intro to Parametrics. In this video, I'm going to teach you how to eliminate the parameter. So basically what that means is we're going to take something that's in parametric mode and we're going to eliminate the parameter and get an equation that's in rectangular. So then it would just be a single equation rather than an equation with x and y in terms of t. When you eliminate the parameter, if that's all you're asked to do, you don't necessarily have to solve for y. It doesn't have to be in y equals. It is often helpful if it's a y equals equation because then you will know what it should look like in terms of a rectangular graph, but it's not necessarily necessary. Okay, so sometimes you want to also kind of gauge and look at your two equations to see which one would be easier to solve for t. So if this was my first example, I would be thinking that the y equation is actually easier to get t by itself because I don't really want to be dealing with plus or minuses and square roots. So if I were to do that, I would get the y by itself by dividing by 3. And now I have an equation in terms of t. So basically you're using substitution. And so then you're going to take that one equation and substitute y over 3 in for t in the other equation, which would look like this. And then if you did some simplifying, you don't have to do too much, it would end up being this, y over 3 squared minus 2, which essentially is y squared minus 9 over minus 2. Okay, and then if I knew this is an x equal equation, I don't necessarily have to spend my time getting y by itself. I can if I wanted to, but it's not necessary. Okay, so let's try a few examples. So number one, for each problem, rewrite it so that it's in rectangular. So get rid of the t value. Both of these are pretty simple, so it actually doesn't matter which one you want to get rid of. But since it's pretty easy, I'll just get rid of the x equation. So I'll solve for t. So all I had to do was add 2 to the other side. Now I have this equation, and I can take this x plus 2 and substitute it in for t into the other one. And when I do that, I end up with this. So y was 2t, and then if I do some quick distributing, I get 2x plus 4. And we all know that that looks like a line. Okay. The only thing is in rectangular world, this would be a line that goes on forever and ever and ever. But you have to remember that t was restricted parametrically. So what you could do is now you could go back to the old way, which is take these t values and plug them in and get a table of values and just plot those points. Or what you could do is draw 2x plus 4, because I know you guys all know how to do that, and then erase the endpoints. So how would I know where it started? Well, I would plug in -1. So my y value would be at -2, and my x value would be at -3. And then, which you could see here, x is -3, y is -2. So that's where it starts. And then where does it end? You would plug in 4, so the y value would be 8, and the x would be 2. So this is just the part of the graph. And then remember when you're graphing in parametric mode that you do want to have the arrow to indicate the direction. So that's it. Let's try another one. Number 2, this one would again be easier to get x by itself. So I'm going to subtract 2 to the other side, and now I have t. Now once I have t alone, I'm going to plug that into the other equation where I see t, which ends up being t squared. If you were to multiply this out, you would end up with x squared minus 4x plus 4. However, this one, the y squared minus 2, that is actually easier to graph because that's in vertex form. And so your vertex would be x is at +2 and y is at 0 because it's plus nothing over here. Okay, or again, you could go back to the old way and take your t values and plug them in and get the sketch of the graph that way as well. So either way, you now have all these different tools. But if it does ask you to rewrite the parametric equation, that's all you have to do. Figure out one of them to be t, plug it into the other one, do a little bit of simplifying, and then there you go. So what I would like you to do now is pause the video for and try number 3 and 4 that's on the worksheet, and then come back and I will show you the answers. So take a second, pause it, and then come back. So here's the answer to number 3. Again, it was probably easier to get x by itself. And then you kind of need to figure out where your starting point is and when your ending point is. And then here's the answer to number 4. You got a cubic that's been stretched by a half, but you only want part of it. And that's basically how you convert from parametric to rectangular. To go the other way, you'll look at the next video where you will write equations in parametric, and that will be converting the other way when something's in rectangular, how to put it into parametric. Let us know if you have questions.